actually use the lens of media or media intelligence, as we've been calling, to sort of highlight some of the possibilities that computing affords us in domains that we typically don't think about as a computer science problem space, right? About representations of people, about like processing audio and video and text, and and trying to get insights about stories, etc. So it's super exciting to be here today, and many thanks to Google and their exploreCSR grant mechanism that kind of enabled us to bring you all together in doing this. So one thing that is what I am extra proud here. This is like run for students by students, right? Like this is purely driven by you all, and that's why I sort of try to be sort of in the background and just let you lead this and show and so the amazing mentors and role models we have here, who've been, and I've been seeing all the Slack chats and this and that as they were planning, meticulously the various aspects over the semester. As Kathy pointed out, right, it's been, the semester demands still being in the midst of all this, the COVID, and as we are sort of dealing with vaccination, new things happening, peaking and getting better. So we're in a good place even there, right? Like, so it's exciting time actually to celebrate. So big shout out to all the mentors, Amrita, Ramita, Digbale, Dylan, Rajat, and so on, and the coordinator, Krishna Samandapalli, who also along the way finished his PhD and heading to Google, will be sort of alongside. The other person I want to thank is Dr. Zoo Kim, who's been an amazing mentor and who gave a very inspiring sort of, he shared a talk and shared his own journey just to show, right, people come into computing along various directions and pick up everything. I hope that, this experience, at least, vetted like one angle of computing for you to pursue more, hopefully with a graduate sort of, degree, perhaps a PhD for some of you, but also careers in computing. Also learning and education happen in the job, right? Like, Dr. Kim, shared his own sort of, pathway going from computer vision to other areas and back to, so a lot of possibilities here. So really, thank all of you for your generosity of time, intellect and mentoring, helping each other. And I hope, this hackathon kind of is a nice culminating sort of an event. I'm super excited to see the results of the hackathon. So thank you again. Thank you, Kathy. So sort of, I can't, underscore how much, Kathy, you've been the glue and sort of the force behind making this happen. So thank you. And let me hand it over back to you.
Okay, all right, Dr. Kim, can you share something with us too?
Okay, yeah, thank you, Kathy, and thank you, Professor Narayan. And yeah, let's celebrate. I'd like to congratulate everyone here who has participated in this wonderful program. So what you learned, the exciting stuff on image and audio processing and machine learning are definitely something, definitely not something you can easily learn from anywhere else. I really appreciate all the PhD students who gave the wonderful lectures and mentored you. I actually skimmed through some of the lectures, and man, they're very advanced. So it might have been really challenging for undergraduate students to understand all of these details, but I think it's definitely a great thing to learn about them, be curious about how these things work, ask questions about what you don't understand, discuss them, and gather together to find a way to actually use this cool technology. So after all, that's what computer science research is all about. So I'm very excited to see the cool things you have created through this program. So I want to go back to the talk I gave you when this program started. I'm glad to see that you are becoming more and more prepared to do cool things that matter. So once again, congratulations everyone, and have fun today and fight on.
Awesome, thank you.
Thank you, Dr. Kim. Okay, I think we did share the agenda today in the Slack channel. So we will share some highlights and then we will jump into the presentation soon. So let me just present the highlight and we will have Krishna. Yeah.
Thanks, Kathy. And thank you, Professor Shri and Dr. Kim, for your remarks. How is everyone doing? I see a lot of familiar faces here. It's nice to see all of you. How is everyone doing this Saturday? Good. All right. So I'm just gonna lay out briefly how the rest of the quote unquote hackathon would go and just give some highlights. And I agree with Chris. I'm so glad the finals are finally over. All right. So okay. So at the outset, I want to say it was a great learning experience for us because this is the first time we've done an exploreCSR workshop at USC through CCMI, and it has been a great experience. And one of the biggest outcomes of this workshop is the videos that Dr. Kim mentioned that is up on our website. I can tell you from the interviews I had to attend, this is a really good resource for fundamentals, also working through the workbooks and all that. And these were designed to be exhaustive because you can always go back, revisit them, and hopefully ask us questions. And if you're stuck somewhere, ping us. That's how they were created. So they're quite exhaustive. So you can always go back and look at them. And in terms of outcomes, I want to mention the one biggest outcome I hope we achieve, at least in some part, is the community that we've all created here. So I encourage all of you to continue to participate and propose new ideas within this computational media lens that Professor Shri was talking about, where we're using computer science to understand how media, different aspects of media are portrayed. Also, remember, we are a resource. This exploreCSR, we got to know you a little better. So we're here. If you want to talk to us about how to prepare for interviews or code jams or review your resume or CV, we're always available. So we want to kind of have this community going that we all started through this exploreCSR. And finally, echoing a lot of people's sentiment here, it's been a pretty hectic semester, right? With all the virtual learning, courses, homeworks, exams, and so on. So it's been a learning curve for all of us. And any feedback you have would be super appreciated. Like, come back to us with ideas or, oh, we can do this better, or some part of it that you really appreciated. So any of that would be great, really welcome. Before going into the rest of the agenda, I'll pause here. Kathy, do you have anything to add to this?
Yeah, so speaking of feedback, in the chat room, I'm posting a post survey link for all you guys to fill in. Remember, you guys did a pre-survey, and then now this is a post survey to just collect insight and where you guys are and what you guys think about this program, because we don't want to, like Krishna say, this connection you build here is gonna last, and in the future, or if we have anything similar to this, we're gonna maybe ask you guys for help, or if you guys are interested in participating more, you're always welcome. So any feedback from you guys to help us make this better in the near future is always very helpful. And definitely after today, don't forget about us, the Slack channel is still there. The resources from our mentors are still available to you, whether it's technical or personal, pursuing a higher education or anything, the community is here for you. Yeah.
Absolutely. May I add one thing to that? Actually, thank you for bringing it up, Krishna and Kathy. Yeah, feel free to, reach to any of your mentors, to me anytime, right? For professional, personal, any of these advice, talking to careers or higher education. We are here, and I'm hoping also, you would consider down the road becoming mentors yourself. So actually, carrying this and bringing more a newer generation of people excited and interested by these kinds of ideas. Thank you again. And yeah, as Kathy pointed out, you're connected and you always be, and that's important to underscore.
All right, thank you, Sri. Yeah, and on that note, I'll add one more point. One of the goals of exploreCSR with CCMI is that encouraging you all to think of pursuing graduate school. And personally, having finished graduate school recently, I can tell you that it's a very rewarding experience. It's hard, but it's definitely rewarding. So I'll leave you with that thought. And before we, next slide, please, Kathy. Before we jump into the teams, I just want to say we are using the word hackathon loosely. So we changed the format a little bit to have the projects today mostly focus on proposals. And some of different teams have a different format or style. Like some of them have a proposal, some of them have a demo, some of them have some analysis. So all that is good. The main objective here was to have you all think about the problem and think about where to look for things, sort of issue spotting. What is the issue? How do I address it? And I hope in some extent you have the tools to sort of address it. So the rest of the session, this is how it'll work. I'll just mention the team and the mentor and the members of the team, and I'll hand it over to the team. So one of you from the team, share your screen, please, and take it over from there. So each team will get 15 minutes. Talk to us, including questions. So talk to us about what your thoughts were, how your proposal was set up, and what your future plans are. Sounds good? Any questions, comments at this point? All right. Oh, and in the meantime, while you're waiting for other teams, make sure you answer the survey. Regardless, just click on the survey and keep it open on your computer. So after the workshop session, you can answer them. Your feedback is very important to us. All right. So the first team, mentored by Dylan. The first team mentored by Dylan is called ScriptBot, with Komal, Amy, William, Pooja, and Chloe. Off to you guys.
All right, so I'll just add a couple things on, just introducing what our team looked at. So in particular, we chose to use text as the modality for which we're analyzing movie scripts. So what my team will be presenting here is potential applications for text, as I mentioned, to analyze movies. And I did just want to say that I really appreciate them for their thoughts and ideas, moving throughout this program, and that it was a kind of a lot of, information, a lot to learn, a lot of introduction. It's a lot of, it's kind of a difficult task that we're setting in front of them. But I really appreciate the work that they put in. And I think that a lot of the background that they've gained with how to think about problems and how to set it up and how to perform the analysis is great going forward. So I really appreciate what they're presenting here. So with that said, I'll be running the slides in the background, and I'll turn it over to Amy.
Okay, so first off, I just want to thank Dylan for being a great mentor throughout this entire semester, and also my team members for working on this project proposal with me. So I'll be presenting along with Pooja our natural language processing proposal. So I'm Amy.
And I'm Pooja. Nice to present.
Next slide, please. So our project proposal was implementing an algorithm to pinpoint key similarities between film scripts and recommending films for moviegoers to watch. And our intent with this was to provide viewers with films that have similar topics to a favorite movie of their choice, and also to reduce the time individuals are searching for relevant films to watch on platforms such as Hulu, Amazon, and Netflix. So with that, just to keep in mind, factors that make up our favorite movies include finding features or characteristics through movie scripts, and also discerning similar plot motifs between the scripts. And our motivation was really learning how to apply machine learning to media data sets, including understanding how these recommendation systems work for everyday streaming services, such as previously mentioned Netflix, Amazon Prime, Hulu, and more. So the factors we thought about while moving through this project proposal was really what features determine script similarities. And we noted that frequency of keywords appearing in the dialogue, as well as how to represent scripts to analyzable numbers. And so creating a matrix of keywords and their importance, which is TF-IDF features, how many recommendations we could provide, which we chose 5 for simplicity and accuracy, and also noting ways to assess the performance of our algorithm. So movie preferences are subjective and dependent on other factors such as cast, budget, popularity, and to also just keep those factors in mind. Our domain was mainly film media, as we were analyzing film scripts and also recommending movies. Our data set was film corpus, which divides movie scripts by genre, and the database has more than 960 films. And then our user base was movie enthusiasts.
Thanks, Amy. So now I'll talk us through a little bit of our implementation. So just to begin, Dylan gave us a really great example of how to apply machine learning to movie script data sets. So we built a genre classification system. So we wanted to predict what genre a movie is based on the film script. For simplicity, we limited our analysis to 3 genres, so action, comedy, and drama, just because we thought that they'd be pretty different from each other. And so this gave us some really good insight into the machine learning process. So we learned how to process our text files for the movie scripts, where we removed white space, markups, and other things that could just add noise to our data. It also taught us a foundation for the concept of cross-validation. So learning how to divide our data into a training set and a test set to get good results. We also learned the concept of TF-IDF, which is how we determined how important words were in our movie script. So TF-IDF stands for term frequency inverse document frequency, which sounds like a lot when you first hear it, but really what it means is we kind of take out words that happen very often. So words like a, the, us, we, things that happen a lot but don't really have any meaning. So that's what term frequency means. Inverse document frequency is how often does it appear in different sets. So in action movies, we could hear a lot about battles and friends. I'm not coming up with the characteristics on the fly here. And we can see that that might differ from, let's say, like a historical movie where we would get more context and just a different set of words. So that's what TF-IDF means. And that was kind of a really big concept for how to represent our data. It also taught us about how to understand metrics for testing the performance of our algorithms, such as accuracy, precision, recall, and F1. Next slide, please. So from our genre classification system, we had the following results. We got an accuracy of 52%. These results were better than our baseline classifier, which basically just looked at the proportion of each genre in our data set, but it still wasn't a very high number. And we were a little confused by that. So we thought about why this could be. And it was really that there are factors other than the script that determine genre. So if you think about some of the movies that you watch, things that determine genre could be your setting, the music, just the overall ambience of the movie that might not be captured so well in the words on the script. Another factor was that we needed some more pre-processing done on the script. I mentioned a little earlier that we tried to remove white space and tabs, but there's also things like set directions and the setting descriptions that might kind of interfere with the direct data that we want to look at. Here are some other formulas for precision, recall, and F1, which are some other machine learning metrics, but they were all pretty similar for our classification system. So then I would like to transition us back to our recommender algorithm. So now that we learned the general process for how to implement machine learning, we wanted to look at our specific problem. So here was kind of our workflow. We wanted to look at a movie. So let's take The Avengers just as a guiding example. That falls under the adventure genre. And if we really like that movie, we wanted to see what movies would be similar within that genre. So that is the goal of our recommender algorithm. And to look at that, we use something called cosine similarity. So you can see the formula for cosine similarity down at the bottom. It looks like a lot of math, but the algorithm really wasn't that complicated. It just looks at how often similar important words are repeated in different documents. So for us, that would be movie scripts. And it builds off that same term frequency, inverse document frequency representation as the genre classifier. So we didn't get to fully implement our recommender algorithm, but here was a really good example. So I mentioned the Avengers movie. Let's compare that to another adventure movie. So we have Mission Impossible Fallout. You can see that based on the results for analysis, those movies were 47% similar. Let's compare that to a pretty well-known romance movie, 10 Things I Hate About You, and you can see that that had a similarity of 38%. So it's not a huge difference, but that could be due to differences in setting, cast, things like names, but there is a difference to be noted. So kind of wrapping up some of our lessons learned, as Amy said in the beginning, a really big shout out to our mentor, Dylan, who really helped guide us through the whole process of learning how to apply machine learning to our movie script data sets, as well as the entire exploreCSR team for all of the workshops and helping us build this community. We really learned about how to, again, leverage this technology to engage with the media sphere in new ways. Thank you. We'll take any questions.
All right, thanks Team ScriptBot. Let's all unmute and give them a round of applause. That's a little trick I picked up for the Zoom calls. All right.
Very cool. Very clear presentation. Nice ideas. Excellent.
Any questions, comments?
So
right.
what was one surprising sort of, or challenge that, you guys faced and, that you were able to, work through it and had an aha moment?
That's a really good question. I think that something that really threw me was seeing that low accuracy at the beginning. I was like, oh, we put all this work into our algorithm. Why does it not work as well as we want? And that was admittedly a small setback, but it really informed us as to what other factors are going on that we might not just be able to capture with the technology. And there are other forms of analysis that I'm sure that we'll see in the other presentations, looking at the setting, the costume, to acknowledge all of the parts that go into making a movie.
I see Chris has a question.
Yeah.
Oh, I was just wondering, because I see that there's an example of Mission Impossible and Avengers, and then the Avengers in a romance. Were there any, could you give an example of some of the specific similar language, maybe things that stuck out, or maybe something that you didn't really expect to be part of the adventure genre, but there was that similarity between the two movies?
Yeah, that was something that we wanted to get to, but ran out of time. was looking at the specific features that really characterize the movie. So as Amy kind of mentioned in the beginning, we wanted to know like what makes a movie enjoyable to you and kind of try and pinpoint those characteristics. But this was just like a purely like sentiment, like what are the words being repeated? Does that kind of answer your question?
Yeah, thank you.
Right. I have one comment, Amy, Pooja, and team. This is great work. One of our objectives here was not necessarily to just apply, deep learning or tool. That's good, but not just that, but to kind of focus on your fundamentals and kind of think through the problem. And so happy to kind of see that come across. One question I have is, what next? Like, say, if you have time to continue working on this, what would you like to explore more?
Yeah, that's a really great question. So kind of as Amy mentioned earlier, some of our motivations were to understand how common recommender systems work. When we were talking earlier, we were talking about like the Netflix Watch Next. So obviously Netflix uses something a lot more complicated than this just because of the sheer volume of data that they have. And a lot of that uses like user subjective data, people that leave reviews on movies, things like that. And really incorporating all of these other aspects would be how to improve this and kind of learn more.
Yeah, that's great. I don't think there are a lot of recommender systems that incorporate script similarity, mostly because I don't have access to it always. But that's a great idea. Good. All right. Any other last questions, comments, thoughts before we move on? All right, let's thank the team again. And the next team is mentored by Digbale. That the team name is FPS. You'll tell us what FPS means. All right, with Caroline, Christopher, Azrin, and Pallavi, on to you guys.
Yeah, I'll just briefly introduce my team and what we worked on. So yeah, first of all, they were like a great team to work with. They really did some great work analyzing the data and like thinking through the problem and asking very nice questions. So our team name is FPS, and FPS means like frames per second. And what the team looked at was analyzing movies, mostly through visual elements and like additional metadata across genres and individual movie elements. So I will hand it over to my team to go through the slides and just describe what the project was and like what were key findings. Yeah.
Thanks, Digbale. Yeah, so I'm Chris, and I'll be presenting with my fellow FPS teammates, Azrin and Caroline. Sadly, Pallavi could not make it. But this will be fun nonetheless, because I think it's the perfect segue from the previous team. They're looking at script analysis. And then with our team, we're really looking at what's within the frame, the setting, the objects, the people, the color, the lighting. And it was just really cool. A special shout out to our mentor, of course. He had a great selection of films, honestly. So it was great to have a mentor who is very passionate about movies, and also to kind of lead our team and show us the ropes with this. So in terms of the broad overview, our task overall was movie analysis, specifically film analysis through mise en scene. And then in terms of the impact we're seeking, we all decided that this could be a very, very cool tool to measure different aspects of movies. Some of those aspects include gender distribution, box office returns, which is on the metadata side, lighting and color tone, and object placements. And through that, be able to do genre versus genre comparison, but also look within genres and see maybe how films have changed over time. So our overarching goal in that sense is really to understand individual movie elements, and then the similarities across different film genres.
So to go over our motivation, something that we can take away from our project is using the gender distribution tool we mentioned before. We can compare it across genres and make conclusions about the social relevance in terms of representation if there are differing amounts of representation among the genres we chose. Secondly, we can make inference about how movie settings have changed over the years. Among the clips that we've chosen, we've had a very wide range of time. So we could compare the earliest clips from 1960s to the later clips, which are from the 2000s. And specifically, we can compare the difference between genres using what objects are more common within this genre versus another genre, how much money this genre made compared to a different genre, and then like the elements within that maybe make some inferences of why they had greater revenue. And then of course, gender distribution, like I mentioned before, would be a very strong impact. Next. So the things that we considered, the elements that we analyzed, we can split into two like sections. There is the broad factors, which are the entire movie, and then there are character factors, which are specific people within the movie. Among the broad factors, we had ambient lighting of the scene, the color palette, the objects within a frame, and then the box office returns. And of the character factors, we only did gender, but other things that we could consider would have been like the age of the character, who the actual person was, like the actor, and then the awards or nominations that that actor won. Next. So here's an overview of all the actual movie clips we used. We had a total of 82 clips that we took from Fandango movie clips, and we used 4 genres: action, drama, romance, and horror. These are a list of example movies from each of the genres that we chose. So they're pretty popular movies, and we didn't use the entire movie, we just used clips that we took, and the average clip duration was around 2.5 to 3 minutes, so a couple thousand frames. Next. So within the building blocks we used, we had an object detector, face detector, color palette, ambient lighting, and then metadata. To go into more detail, the object detector we ran frame-wise, and we had the bounding box info, the B box, from the top left corner to the bottom right, and we used that to determine where the different objects were on the screen. Similarly, we did that for the face and gender, but we used the Google SDK to find the actual info from that data. For the color palette, we had a frame and we used the picture data, we clustered it using k-means. And from that, we had different clusters. We made a histogram of relative color frequency. And you'll see later, but our output is an actual color bar graph, which each color is the centroid of those color data. So we can see the main colors of a frame. For ambient lighting, we took the RGB pixel data and converted it to the LAB so we could get the lighting data. And we took the average light from each frame and converted that like to a number basically. And you can see we have like a line graph that will show how the light changes within the movie clip. And then for metadata extraction, which is like revenue, we took the box office data from Box Office Mojo. Next. So now we'll talk about our results. We, like before, split the results into 2 main sections: genre-specific analysis and movie-centric analysis. For the genre-specific analysis, we had gender distribution, object distribution, and box office returns. And then we will have graphs for lighting and color palette for some specific ones we chose.
So for the results for gender-specific analysis, first starting with gender distribution, for female screen time per genre, we found that horror movies scored the highest with a 52% female screen time, while action movies only had 25% of female screen time, which was the lowest. Next slide, please. And for average worldwide box office returns, we found that action movies earned the highest with $537 million, while the romantic movies earned the lowest with the $140 43 million. Next slide, please. And we also compared the box office returns for all 6 action movies in our sample. And we found that Jurassic Park earned the highest with over 1,000 million, and Johnny English earned the lowest with about 160 million. Next slide, please. And this is the result for our object distribution. The graph shows 10 objects with the results of 2 movies. In the blue is Mission Impossible, which is an action movie, and orange is Pride and Prejudice, which is a romantic movie. And as expected, mostly vehicles and outdoor objects are present in the action movies, while indoor and household objects like potted plants and vases are seen in romantic movies. Next slide, please. And for movie-centric analysis, this is an example of a horror movie. And we graphed the ambient lighting for this frame. And as you can see, it has a very low lighting condition because the graph has very low. It's graphed with very low brightness in the frame. Next slide, please. And to compare with the previous horror movie, this is an action movie. And as you can see that the graph it's pretty high, and it's compared to the horror movie, this action movie has a very higher ambient lighting. Next slide, please. And we also generated the color palettes for different movies. On the left is a romantic movies color palette, which uses mostly warm colors, and on the right is a dramatic movie, which is using very cool colors. Next slide, please.
So that was all super amazing. Thank you so much, Caroline and Azrin, for breaking down our results. In summary, in terms of gender, really, it was interesting to see that the lowest percentage of female screen time was in action genres, while the highest percentage were in the horror genre. At first, it may seem a little bit shocking, wow, there's such a big difference, but when you really look at much of the tropes and much of what's very common in those genres, a lot of times action genres will have a male lead, where in fact horror, on the other hand, is one of the genres that primarily features female leads. In terms of box office returns, without a doubt, we can see that the action genre had the most in box office returns, with Jurassic Park standing out. And that was almost double of the horror genre. We can't necessarily say that the box office returns are just because it's action and not horror. And if we were to carry on this exploration, I definitely think looking at who's involved with the movies would be very big, because obviously with Jurassic Park, very, very famous director and a very A-list star-studded cast. So those could all be contributions to why box office revenue was higher. And I think it'd be very interesting to include those additional pieces of metadata, such as awards, accolades, and also the cast and crew to kind of see how that correlates with revenue. In terms of lighting, the main takeaway was darker frames in the beginning and lighter frames near the end. Now, looking at everything in conclusion with our movie-centric analysis, I'm really, the RGB to LAB color space mapping can help a lot in extracting ambient light condition. And another thing that we took away was extraction of color palette of movie frames is possible using the k-means clustering. So I did mention, possibly those additional pieces of metadata, such as awards, accolades, cast and crew. I think that ties into, some of the future work and the possibilities with this. So in terms of future work, really using kind of the building blocks developed for this kind of mise-en-scene analysis, creating a tool for computing both within genre similarities and across genre comparisons through lighting, color palette, object detection, face recognition, could be a very, very interesting and I think applicable tool. In terms of what that looks like, whether it's used in an academic setting to look at past films and look at how films changed, or used in a more commercial setting to look at what's currently the most popular, what's the hot new trend. I think the options are endless with how applicable this could be. So yeah, that's kind of wrapping up our project. And again, a huge thank you to our amazing mentor, Dick Blay, for showing us the ropes, for encouraging us, and for leading us throughout this project. And thank you to this entire exploreCSR group and team.
Great job. Let's unmute and give them a round of applause. All right. We'll open it up for questions or comments. Thank you, Team FPS. All right, I'll start off with a question. So the 82 movies you picked, what were you thinking? No, you're fine with time. What were you thinking when you picked those 82 movies? Like, I would like to hear your thought process.
Yeah, so I can speak a little bit onto that. So one was we weren't able to really look into movies over time, but that was one aspect, was choosing not just action movies from the past 4 years, but really trying to go back to the 60s and have a selection of movies throughout the years. I know we weren't able to go into that, but that was one of the initial factors. Was we're really interested in seeing how has the action genre changed from the 60s to the 2010s. And then another was we really did not want to factor in indie films or art house films. We're mainly looking at mainstream films from each genre. So notable names. We weren't really looking at films that are not mainstream, I guess, in the sense. So those were kind of the two ways we picked out the films.
Makes sense. Thank you. Shri. Yes.
I had a more high-level question for Team FPS members. Was there like a thing about computing, right, that was sort of surprising for you, that you never thought about? Hey, this is a facet of computing through this sort of experience. Nice project, by the way. Really cool presentation and work. Kudos to all of you. If Chris or Asbren or Caroline wants to share one thing that just surprised you or you never thought about because of exploreCSR or this experience.
I can go. I think, for instance, I think of computing a lot just in terms of numbers. So like a lot of number crunching, math, kind of like science stuff. So I think it was cool that we were able to use this like specific pixel data to be like the number. I think that's something that you don't really think about, since our project was very visual based, but computing, I think, is usually very computation based, as it sounds like. So I thought it was cool that we were able to use the application like this.
Right on. Thank you, Caroline. Others?
I just want to add a comment. I think I learned a lot from this presentation. Like, I did not know the color palette, like changing the RGB format was useful for ambient locations. So like, really good job, and shout out to Digdalai. I know he worked hard on this, and great presentation, guys.
Thank you, Amrita. Yeah, that's good. That's a good point. We're all learning lots from you guys, actually. Nice.
I just wanted to add really cool team name, guys. Really like that.
Yeah, nice.
Azrin, were you going to say something?
Yeah, yeah. I because this is my first time like working with movies, so I didn't really know that we can like actually like look at frames and see the brightness changing. So I thought that was super cool to work with because before I only worked with like programming like with numbers and things like that, just like Caroline said. So this was super cool, and I'm really grateful for Dick Belay for like leading us through this whole project. It was really awesome.
It's cool. Yeah. Through data exploration, different kinds of data, right? It's awesome. Yeah. To compute with. Yeah.
Oh, Chris, go ahead.
Yeah, I have one last thing to add. Yeah, so as somebody who doesn't have any computing background, I think that this is really great because I had a film background originally. So it was almost like the easiest, most comfortable way to understand it. And by no means have I really understood it. I think still so much of it is confusing, but special shout out to Dick Belay and the entire team to make this the most approachable way for exploring it within the confines of course, remote learning and everything. And definitely, at first I was expecting myself to be turned off or scared away, but even though I still have all these like questions and a lot of like, I don't know what's going on, it's more so from a place of curiosity. So I think overall this was very cool. Thank you.
Awesome. Two thoughts before we move on to the next thing. One, mise en scène or the placement of things in movies it's a really fascinating thing if you want to continue exploring that. I'm obsessed with color palettes. Whenever I see a movie now, I automatically register the color palette. And also, fun fact: almost every director has their signature color palette. Like Christopher Nolan, for example, has very dark and cold, even when he's making regular movies, just for fun. And two, quickly before we move on to the next team, can you tell us how you made the slides? I would really like to make the slides that way.
Oh yeah, so just on Canva, actually, it's a free online site for anyone who just wants to spice up their slides. If Google Slides or PowerPoint gets boring, just head over to Canva. It's free to use. And yeah, I've been using Canva for all my presentations, and I always get the same response. So please go and use it. It's free and it's really fun. You can make really cool things. Yeah.
Right on.
Good. They better pay you for the advertising. All right. So the next team, mentored by Rimita, is called the Exploring Tinkerers. With Jessica, Sarah Lim, Shika, Carrie, and Brandon. On to you guys.
Hey everyone, I will briefly introduce the work we were doing. So we were interested to, so we were interested to learn the role of machine learning in music and media. So one thing that I would like to mention that in this process, along with my mentees, I have also learned a lot, and I want to thank them all. I would say we couldn't finish all that we have planned, but at least we learned a lot during all this. And also I would like to mention while we were formulating the problem, I consulted with Dylan, and his inputs really helped us to formulate the problem. So thanks Dylan for that also. And over to you, the music and AI team.
Hello everyone. So far we've read some scripts, We've watched some movies, but now let's listen to some music. So this is Music and AI, understanding the role of machine learning for music and media. So our team is called Exploring Tinkerers, and it's made up of me, Brandon, Angeli, Sarah, and Jessica. And we were mentored by the wonderful Ramita. So starting off, what is the motivation for working with music and doing this project? Well, as the world is becoming increasingly dominated by music and things like movies, social media, advertisements on TV, we felt it was important to greater expand the role of machine learning in music, which is still largely underdeveloped, but growing in more knowledge every day, so that we can greater learn how to implement these things of AI and machine learning in meaningful ways. Another motivation is that we also kind of have this greatly expanding auditory landscape, and having a greater understanding of how audio works can only advance our knowledge of it. Also, numerous people on our team have an interest in music and wanted to work with it in any capacity. So doing this and having a passion for music and having this in this project was just a great opportunity for those people to work with it. Nextly, what exactly are we doing? Our intent with this project was to analyze audio, particularly music, and how machine learning can predict the genre from different music samples. So we first started off with music audio. We took music from a very large musical database with a variety of genres, and then we used some of the tools that we learned in the workshops, like feature extraction, and we looked for specific music features such as tempo, instrumentalness, and speechability. Then we next, using AI and machine learning, we looked at those features and then tried to kind of create genre labels from those features. And then with these labels that you create through machine learning from these features, our intent is like, and for also any other future projects that come in this field, to improve the process of selecting music from databases, and also just streamline the process of picking audio from different places and databases. So we just hope to improve that as time goes on and with more research being added.
So using the Spotify web API as well as Python, you're able to extract a lot of features from a specific track. In the case of the Music for All tracks we used, we were able to use the Spotify ID for the tracks to extract these features. And these features are like danceability, which is how suitable a track would be for dancing based on musical elements like tempo or rhythm stability. And these values range from 0 to 1. Energy, also ranging from 0 to 1. Loudness, speechiness, which is how much spoken content is in a specific track. Instrumentalness, which is kind of the opposite of speechiness in how in predicting the probability of whether a track contains no vocals whatsoever. Liveness, which detects the presence of an audience in the recording, so how likely a track was performed live. Valence, which is a measure describing the musical positiveness conveyed by a track. For example, a high valence value of like 0.8 would convey a more happy or cheerful song, and a low valence of say 0.2 would convey a more sad or depressed track. And tempo and a lot of other things. So using the API, we could extract these features and use other Python libraries to analyze this data.
The Music for All dataset contained two types of files, .csv and .tsv, which contain different types of song data. Specifically, we had 4 .csv files and 1 .tsv file, and that data ranged from lyrics, genre, listening history, to artist and album name. The .tsc file contained the path, tags, and theme of each song in the sample, and our data sample included over 15,000 users and over 100,000 songs.
So what's our one big finding? So from the paper of the image as posted on the slide, the biggest finding was that loss functions matter, especially focal loss, as it improves overall performance on imbalanced multi-label data sets. And compared with a couple other loss functions, such as class balance loss and distribution balance loss, the focal loss function produces the best performance, both in terms of PRAUC and ROCAUC. And to provide some further context on what PRAUC is, it's a curve that combines precision and recall in a single visualization, meaning that the higher on the y-axis the curve is, the better your model performance. For ROC, the curve is a graph showing the performance of a classification model at all classification thresholds and plots two parameters, which are the true positive rate and false positive rates. And with these findings, the final ensemble was made by averaging the predictions from models trained using the loss functions, and it had achieved the highest performance. The purpose of this was to build a robust system that accurately predicts multi-label tags, such as mood, theme, or genre associated with a piece of music, regardless of the frequency of such labels. And this was achieved through loss functions, more so a focal loss, but more effectively with a combination of the different loss functions.
We learned two key things while working on this project. First, possible real-world applications represent diverse populations. For instance, the Music for All app provided a simple interface for Alzheimer's patients to find music recommendations, and this created a personalized playlist based on age and personal interest, and this is especially useful for elders with difficulty expressing their preferences. And two, the importance of loss functions for model training to quantify performance, since accuracy is key for model training, and loss indicates how far an output is from the desired target.
So that was our presentation. Thank you for your attention, and now we'll open up for any questions.
Great job, Shikan team. All right, any questions, comments?
Yeah, I actually have a quick question here. So you had mentioned that you used the, or you looked at the Spotify features, which are, I think, really, really cool because, you know, they're kind of a high level way of looking at it, and they offer a lot of interpretability. And so I was just wondering if you know, for any task in particular, if you had a chance to look at how they would be used for, you know, some classification task, and if you got a feel for, you know, is some feature more important than another, or groups of features more important? Any kind of ideas along those lines?
For me, I was able to look into using the Spotify library, which is the Spotify API with Python. And I was experimenting using the search method or feature and using queries with the various features, but I hadn't gone so far to analyze the data that we received.
Personally, some ideas that were thrown around that unfortunately we didn't have any time to pursue, but was definitely interesting, was that I kind of wondered, like, in terms of advertising, so the music that's used in ads, what kind of features increase user traction and user memorability of these ads. So maybe it's songs that utilize more instrumentals, that's advertisers remember more or are more likely to buy the product, or it's maybe the feature of loudness. So maybe if the music is louder, it's more likely to attract users to buy a product. So I think using these kind of Spotify features are a great way to kind of analyze any kind of particular, higher level process, you want to use, be it for advertisements or for movies, and seeing how that works with, say, images or scripts, and just how it all works together, and how features can come from it.
Yeah, for sure. I think those are honestly really great ideas. So thank you for that.
One thing I just want to comment, right? Like, one, we have looked at all the modalities so far, right? We got text, we got video, we got audio and music, like Chica pointed out, but also I want to see how nicely, each of the teams come across, right? Like, very cohesive. And that's another important part of, careers in computing are these days not an isolated thing, but actually people work in teams and together create like things that are greater than what one can produce. And it's very reflective here, reflected very well here in what we are seeing and hearing from all your very nice presentations. And even though we had a short time and you probed as one slice, a small slice of what the possibilities are, but it's coming across so nicely. So great to see that. Thank you. Yeah.
Great. Thanks, Sri. Chica, those were really good points about ads and music. And it's great that you're all like thinking ahead, thinking to the problem, which is impressive to see. All right. Any other questions or comments or thoughts before we move on to the next team? All right. The next team is mentored by Rajat with Jade, Neha, Miles, Tiffany, and Hannah, called Team Sports. So what do we have so far? We have music, text, and video. And I'll be curious to see what you're doing now. All right, on to you.
I'll give a brief intro. I'll let Hannah and Jade talk about the project in particular. I just want to say from the outset, the team has been super interested in studying representation in media. So I think one thing that fascinated me is that there are a lot of ideas thrown about on how, like, what kind of ideas people are interested in pursuing and how we would go about doing that from an ML standpoint. So I think that's something that really impressed me about the team itself. Also, a quick shout out to Tiffany, who couldn't be here because of the unfortunate time zone she's living in, but she helped a lot. She helped Hannah and Jade a lot out with the project itself. So yeah, I'll let Hannah take over.
Sorry, I had to find the unmute button. Okay, wait, let me present. Awesome. Okay, so our group's topic was the gender breakdown in sports advertisements via audio analysis. So I have this, picture of Serena Williams because she is one of the most iconic women in sports. And I just thought that was a fitting image for this slide. Okay, cool. So our topic, like we mentioned, gender representation in sports ads. So we sort of settled on a research question, which is in green, which is how has representation of women in sports ads changed in recent years? So the impact on individuals or society is that representation matters. So we want to look at how, historically women have been portrayed in sports ads in order to get a feel for what the current, situation is and how we can improve for the future. I know I, was a little girl who played soccer. I know I would watch these Nike ads and appreciate anytime I saw a female athlete. So I know from, my own perspective that this is an area that has a lot of impact on society. So our overarching goal in terms of, our computation learning and stuff is that we wanted to analyze these sports ads, the audio clips, keeping track of timestamps, whether it's a male voice or a female voice, and I'll dive into, exactly what we're doing in a bit. But we want to just look at this gender breakdown within the commercials, and then we can look at, which brands might be doing a good job of representing women versus others, and maybe what the entire industry has been doing in terms of female representation in these commercials. Okay, so our motivation behind this project, we all sort of decided that sports is something we all, agree we all enjoyed. But also we care a lot about representation. That was, the big thing that we wanted to look at. And so I just want to point out that sports entertainment is particularly a male dominated, space. So we want to, I used a pun on the slide, level the playing field when it comes to women being represented in these commercials. But then also the other aspect of this specific project is we wanted to try a project we could tackle. And what I mean by this is a lot of us are still very new to computation and new to using these tools. So we wanted, we had a candid conversation with our mentor, Rajat, and we just said, hey, you know what, we want to accomplish something, but that we're still really new to using these tools. And so we, spoke with him and decided on a project that we could use. Commercials were a data set available to us. So we said, that's our best route. Audio analysis is something our mentor was really familiar with. So we're like, let's do that. That sounds great. So that's sort of why we arrived at this. So what factors did we think about? Wait, sorry, I lost my mouse. Hold on. Okay. Considerations, what factors did we think about? One thing we looked at, or sort of a hypothesis we had, is that maybe women have been featured, more recently. That's a trend I have noticed in terms of commercials. So we were looking for that, but then also we were talking about like the mode in which we collect data. Audio was something that we settled on, but you could also look at the, visual space of the commercial, or you could look at things that aren't video commercials. You could look at magazine ads, things like that. So yeah, we decided, commercials was a data set we had available to us. And then the next step was just picking the sports brands that we wanted to examine. So then this slide is just our domain was sports brands. In the sample, we included brands like Nike, Gatorade, Powerade, Puma, all of these that are associated with sports. So implementation, how did we, do this project? So step one, like I mentioned, was identifying these sports commercials, and then we had to download them from the data set in order to use in the computation model. So the next step was running the audio analysis on these commercials using a computational tool that Rajat, I want to shout out to him. He really helped us with that through a Google Colab notebook. And so what we did was, take those files, run the code on that, and then it spit out like a timestamp diary of whether a male or female was speaking in the commercial and when. So that's sort of how we use that computational tool. And then our main goal was to look at this data, make data visualizations, pie charts, things like that, to really get a visual for the data we're collecting. And then we wanted to look at individual brands and see if we could see any trends, over the years or whatever, if maybe more women have been represented. Or if there's just a general trend in general. So here's an image of just sort of how we went about doing this. The Collab notebook, that's just, a small screenshot, as well as I had a screenshot of some of the collections of commercials we had, different brands, different file folders. So yeah, so our findings, unfortunately, we would have loved to run a lot more like commercials than we had time to. So that's something maybe we could continue to do in the future. But here's an example of one Gatorade commercial that we did run through the computational tool. The picture on the left, we couldn't, there's probably a better way we could visualize this, but if you picture like 12 o'clock being the starting point, and then the commercial sort of continues around clockwise, you'll see that the first little chunk was a male voice, and then it switched to a female voice, and then back to a male voice. So we just sort of added all of that together and arrived at the pie chart on the right, which sort of just said like the majority of the time in that commercial was male versus female. So this is just an example of something that our computational tool was able to produce. Like I mentioned, our goal really was to look at a bunch of different commercials so we could see a trend, and then a bunch of different brands so we could compare, but we just didn't have the time to do all of that. But that was the idea. And then, so the lessons we learned, and Jade, if you want to jump in at all, feel free. But from the one Gatorade commercial, we saw that men took up more audio percentage than women. This is expected. A lot of these commercials we still associate, with male athletes or male character portrayal. But, if we had time to look at all the other ones, maybe we would have found something different. But the main lesson is that sports brands should continue to prioritize, women representation and leveling the playing field because both men and women purchase their brands. So to, continue to inspire female athletes, I think representation matters. So.
And just to jump in, one of the things that you see, like there's a lot of advertising campaigns where you'll hear like, oh, it's the first woman to be representing this brand. And it's emblematic of how we're still within sports as a whole having like competitions where it's like the first woman's doing this, or with the Super Bowl, just this past Super Bowl, it was like the first, like it was like the largest amount of women referees for the first time. So it shows that we still have a lot to grow with the branding part of sports and also just like playing sports themselves. So it would be interesting to see if we got more representation in advertising, how that would reflect to the playing field. No pun intended with playing field again.
Right. And I think data just may be, a really helpful tool moving forward. Like this was a very small project, but I can see, there's a lot of really strong opinions when it comes to women being in sports. And I know just data is a great way to, strengthen some of the arguments that, maybe women should be paid more or women should have more opportunities. So I hope, we can continue to use computation to tackle some of these problems in terms of representation, because data, should help out there. So yeah, here, let me stop share.
Great words, Hannah, Jade. Great work and team. Your round of applause. All right. Any questions, comments?
I just wanted to add a comment. Sorry, Digbalai.
Yeah,
I thought the visualization was very intuitive. The one where you map a pie chart to the clock to sort of show. I thought that was really cool. And, I know you only analyzed one movie, but like, that's okay. The whole point of this project was to just get a feel of the whole thing. And you can keep doing this if you want, like no one's stopping you. So great job on, getting here. Really cool presentation.
Absolutely. And I want to like piggyback on Amruta's comment. Hannah and Jade, you both mentioned you didn't have time to run it, but that's my takeaway from what I've seen in the presentation is that you really motivated your problem well and you set up the whole framework. The rest is running more data and analyzing it. So good job, really good job. But here's my question. What are the other factors you would look at? So I see you put a lot of thought into how you would select your samples. So what other factors you would look at? What next?
So one thing that I thought of that maybe we didn't include in the presentation is, like from an advertiser or someone who works in marketing, from their perspective, maybe they're, targeting a certain audience and that may or may not include women. So I think that's, just something else to consider, because maybe they have, a line of soccer cleats that are designed specifically for men or something like that. That's obviously gonna, like skew the results. But I think, the other factors we just talked about were like where we're getting this commercial, from which time period, from maybe which brand, from which location, all of those things are important. I hope that answered the question.
One other
Oh,
thing
yeah.
I would think to look at is like not all sports commercials have like athletes in them, but maybe seeing which athletes have partnerships with specific companies, since most of the time if you're partnered with one, you can't also do another at the same time.
That's a great point. Yeah,
On
absolutely.
a side note, I just read a New York Times piece yesterday on Naomi Osaka and the brands that she's like consciously choosing to represent. So yeah, I think a lot of athletes are choosing their platforms very carefully these days.
Great. Digbalai, were you going to say something?
Yeah, so great presentation, and like shout out to Rajat and all your teammates for thinking this through, like especially in terms of ads. So I was just thinking, like, since you guys mentioned like Super Bowl, so this can be like analysis over years of Super Bowl to see how sports ads have evolved. That would be like a really nice extension to this like analysis that you have done. Yeah. Great job. Yeah.
Great. Any other questions, comments?
Yeah.
All right.
I wanted to say this was like a really interesting topic that you guys did. So good on you for choosing it. But also, like, another jumping off point possibly is like not only like the duration of how long women are in these ads compared to men, but also how they're portrayed, like what's being shown. Like for a lot of them, they're kind of being sexualized in them, like maybe showing their bodies more, showing more skin. So maybe seeing how exactly what the advertisers focus on, comparing men to women, could also like show some more disparities between them.
Yeah, you're totally right. I think that is also like super important. So you're right. Hopefully, we'll have time to maybe expand this or whatever. But yeah, I totally agree.
Chika, that's a really great point. That's some of the things we really struggle in, like computational media intelligence, right? What, when or what is easier, how is much more difficult. And even formulating some of these things, the fact that you're thinking about it is great. All right, any last thoughts? Great, good job, team. The next team is mentored by Amrita, called Fashion Forward, by Anne-Marie, Rachel, Rihanna, and Sarah. On to you.
Thanks, Krishna. I just want to say Sarah couldn't be here. She's actually traveling right now. But just to say, like, I mean, I was really impressed with this team from the start. I think one of their biggest strengths was how creative they were. Like, they came up with like a really cool name. They were able to think through different aspects. Like, I was really impressed at like how they were so good at formulation. Like they were able to take an idea that was very abstract and like think through the different aspects. And I guess I'll hand over to them, but I just want to say the whole discussion before this is a great segue, because they're going to be talking about how people dress in like different movies. And I guess it's something like a cross collaboration would be really nice,
Hi everyone. So we already got introduced, but to just go over, our team decided to analyze women's fashion trends directed by females compared to fashion trends directed by males. This is our team on the next slide. And we were already introduced, but our name is Fashion Forward, and I'm gonna jump on the next slide. So our goal in this project was to compare the coverage, colors, style of fashion choices, and compare it with respect to male and female directors. We also wanted to target the presentation of different female characters, for example, coverage and how women are sexualized, and the similarities between characters and repetitive patterns. And lastly, we wanted to see the impact. So how the difference impact individuals or the society. During our research, we found some interesting statistics. So for example, female lead characters in major movies are more likely to be objectified or perpetuating harmful stereotypes for women and girls. About 30% of female leads are portrayed in revealing clothing compared to 7% of male leads. These portrayals are tied to a lack of women working as directors and writing and producers. And lastly, male gaze is defined as the act of depicting women in media, a masculine heterosexual perspective that sexualizes women. Okay, the next slide, please. So our motivation for this project was our personal interest and influence, because women are presented differently when under leadership of men versus women, and all of us are really interested in this topic. And we also wanted to see the societal impact. So we wanted to shine light on how women are portrayed in films, which affects how women are perceived in general. So we wanted to show light on this discrepancy, and we wanted to encourage women to come to the field and join the women empowerment and get more female directors, since there is less female directors than male directors.
Hi. So we chose 3 factors to consider. Firstly, the time of release, since fashion trends are not static and they tend to change over time. Secondly, the genre, and this was to see if there are any similar trends in genres such as action, romantic comedies, and drama. And lastly, the gender of the creators, since we will be comparing how they represent women. Next slide, please. So this is our sample data set, and our aim was to minimize the variability, so comparisons are more accurate by comparing films within the same genre and time period, and these would act like our independent variables, and our dependent variable would be the gender of the directors. And another consideration that we thought was important was if the female character was the supporting or main character, and we tried to find films with this same trend. For example, in both Captain Marvel and Atomic Blonde, the protagonist was both female. Next slide, please. And our plan to implement this is to handpick specific frames from the movies and run it through our code. Next slide, please. Thank you.
So our code used this Fashionpedia model that we were provided, and it would basically break down an image from the frames of the movies that we selected into several categories. As you can see, it goes from ensemble to coat, tops, and shorts. And from there, we can get even more descriptors about the coverage or the area and the details about the garments so that we could draw larger conclusions from these. And this is an example of a code output that we got from an image from the movie Iron Lady with Meryl Streep. And then it kind of comes out with 5 segments or 6. And just to walk through the process of an example, how we could draw some information from it would be sorting the groups into like the 2 male directors and female directors, just to separate the data. And then we could look at maybe the frequency of certain attributes of their outfits, as well as just find trends of the coverage. As you can see, there is like a pants attribute that you can find like the coverage or the waist and pattern, and if it's symmetrical, as well as the like sleeves could also be something we could draw a conclusion about the coverage on a body. And then other things could be done with a little more creativity, such as the collar could give insight to how often women are represented in formal attire. And there could be a lot of other accessories and details that we could figure out and adjust this data as we keep going. And I think it is important to note that since we were provided this program, it wasn't exactly fitting our hypothesis that we were thinking about. So say we wanted to come up with more specific attributes of outfits, especially for female outfits, we could probably try to adjust it or just learn more about making it really specific to our solution. And then to kind of put everything in context, it would be really interesting to have this analysis because there is such a discourse on how women are represented in media. And it kind of brought up this film. It's called Misrepresentation, and it covers a lot of firsthand accounts. Specifically, Rachel Maddow and Katie Couric talk about their own experiences in the media industry. But these are, once again, kind of firsthand accounts. So this data could really show a larger trend in the whole industry and just bring to light a lot of patterns and just help us make a bigger view about what's going on. And it would be really important. And thank you to everybody in this program, and especially Amrita. We definitely learned a lot, and it was a lot of fun.
All right, great job, Team Fashion Forward. All right, any questions, comments? Thoughts? I have a thought. First off, really great job motivating what you're doing. I think a lot of us, particularly engineers, get lost in the solution, not the problem. So I was so glad to see that you really thought to the problem. My question would be, what next? So I see you made a lot of thoughtful choices about like the samples and all that. Like if you were to continue or had the thought at the time to continue, how would you like operationalize it at scale? It's a tough question, but I just want to hear your thoughts.
Yeah, I can try this question. I think we'd probably try to choose like maybe a genre to start off in, to kind of just like limit the sample size and really just go through the steps of that one genre, because there can be a lot of factors going into it. So I think that would probably be a good place to start, and then maybe look across different genres then, but that would be a good starting point. If anybody else has comments, I don't know.
Absolutely, and attire, I think, is kind of begins to address one of the questions that Chika raised. Not entirely, but to some extent, at least superficially. So that's a great point. All right, any other questions, comments? Great. All right, this was the last team. So I'll pause now and open up for any questions or comments you have. The mentors feel free to jump in. Kathy, feel free to jump in.
I just want to say, like, for me, who doesn't really have an engineering or like computer science background, just attending the workshop with you all and learning from your presentation and everything, it does give me like a different perspective of how I look at a lot of things. So I just hope like, this can be something that carry you guys along the way, that whether you get into this more or not, like it will give you like a different perspective. Like watching a movie is no longer just a movie anymore, like you get to pick like all and or like notice all these like different little details, and watching a commercial is just not a commercial anymore. Like just be more in the knowns. Like I feel like now when I watch movie or TV shows, I do look for like something that is more detailed, like what is it trying to say or what is it trying to portray? Is there any bias or stereotype in it? So I feel like me personally had enlightened a lot, even though I didn't do any of the project, but just like, looking at what you guys analyzed in the presentation, I myself feel elevated already. So yeah, great job, guys.
Perfect. And just to add quickly onto that, I just want to kind of reemphasize just the importance of being able to kind of think deeply about these problems and being able to kind of formulate the problems, and just how important, just that step is. And so I really appreciate, all your ideas and thoughts towards that. And that kind of approach is very, very universal. So, please kind of keep thinking that way, kind of keep thinking about these problems in a very deep way. It will definitely serve you well. And then just the other thing is, again, for any kind of the, technical details and implementation details, we have provided the workshop materials. So if you ever have any questions about any of that, that's there as a reference. And then us as mentors, we will also be available. If you ever need any help, always feel free to reach out to one of us.
Yeah, just to build on what Dylan said, like all the resources will be there. We as mentors will be there as to guide you in any help you need, like regarding any technical advice or any like going for say for higher education, or like if you want any professional advice, we are here. So feel free to reach out. Like you're always available on Slack or mail or anything. It was really nice working with all of you. Really enjoyed it, and hope to see you in future as well.
I just want to also add, I think like a shout out to Rajat. he even set up like GCP instances and everything. So if you guys want to continue on this project, like there are actually Google Cloud resources, so you can like get your own instance on the cloud and run with it. And that's just there, like just being one of us, and let us know if you want to continue with this analysis. And also I would really encourage you, like I have a lot to think about after all the different projects and the presentations. So maybe there is something your project can also benefit from, like some aspect of the other presentation. So a lot of food for thought. So thanks everyone. Great job.
Thanks, Amrita. Yeah, to echo her opinion, like people who want to run some of these experiments on a larger scale, also, yeah, feel free to ask for more resources, which we have at hand, and we'll be more than happy to provide them and help guide you through those resources. And also, I think another point Amrita raised was that is very thought-provoking. A lot of ideas and a lot of applications which we wouldn't have even thought of just a few years back are being made possible due to these technologies. So I think this was a great way to sort of introduce people from different backgrounds and see how people come up with very creative ideas on how to apply these to a lot of domains. So it was a super cool experience for me. Thanks, everyone.
I want to hear from at least a handful of the students what your experience was. Well, let's do it the cliche way. One positive or one good thing, one thing that could improve. Oh, feel free to jump in. Don't. Yeah.
I'm a communication major and I also transferred to USC this year. So I was trying to just like get involved in different things and I wasn't really sure what to expect, but with getting involved in this program, but I feel like there's actually a space for someone who's not like in STEM by major to participate in computing, which I know is like one of the main goals for the program. And then my one negative thing, which like you guys have no control over this, would just be being in person. I feel like having that technical in-person experience would like help just because it was like new things that I hadn't been acquainted with before. But otherwise, I'm really grateful to have met like so many other students and the mentors, and I'm happy that I participated in this program.
Thanks, Jade. And absolutely, hopefully USC is opening up now. So most of the mentors, they're all in RTH, Ronald Tudor Hall. So if you want to ever stop by and say hi, feel free to. All right, more comments, thoughts? Go for it. This is the last chance you get to speak in the workshop.
I think for me, one positive thing definitely was just the patience and understanding of all of the mentors. I know like it's just a lot, like I'm in electrical and computer engineering and a lot of this still was just very overwhelming to me. So I think like all of your patience and just really your, meeting us where we are at was just helpful because I know like I felt more like it was okay if I don't understand right away versus sometimes, when I'm in class, I feel like I need to be understanding to make sure I get an A, so I think just all of you being willing to meet us where we're at and explain it in a way that made sense to people who, like are still very confused by this type of thing. It just meant the world and it helped this program, be a lot more meaningful to me and I'm sure everyone else in this program as well. And then I guess on that same hand, I think the presentations, they were awesome and I liked how they were recorded so I could go back and rewatch them. But I think still it might have been just like too like broad and big picture, I guess. This is just speaking from my perspective. So I think maybe if we were given like bite-sized tasks or like things that like you lecture on a specific topic and then maybe we can like press play on a line of code and just watch what happens. That might just help connect concepts a little bit better than just like sitting back and taking it all in, which was also great. I want to emphasize it was also really great. So I guess that's my feedback.
That's really great, Hannah. Thank you. Yeah, we will definitely incorporate that. And that's something we started off with, and then, plans of mice and men. All right, thank you. More comments?
For me, like I'm a senior graduating, and I thought this was a really cool experience because I'm also in electrical and computer engineering, and I think a lot of our classes, like they give us maybe the foundation to like learn about this stuff, but this program really put an application to the things we learned, especially with all these presentations, made me realize how diverse the field of computing is and how you don't necessarily have to like be really grounded into the like tiny stuff. Like these kind of team projects bring together a lot of different kinds of people, and I really appreciate I was able to get that experience before I graduated. I think my one like small inconvenience with this was the same thing, was that I was graduating and a lot of this was near the end of the semester, so I had a lot of finals, and then of course I got swept up in this whole like we finally had in-person graduation, so the timing was a bit off because it was, in my opinion, a little bit heavier near the end of the semester rather than the beginning. Yeah.
Absolutely agree with you. What next, Caroline, after you graduate?
Oh, I'm just working. Sorry, no grad
Good.
school.
Oh, no, I worked after, well, my master's doesn't count. May I ask where you're working?
I'm going to Seattle at Microsoft. So yeah.
Well,
Digler
congrats.
Belay was telling me about there is a team at Microsoft that does similar work. That's really cool. So
Well,
I'm glad I got
Rimita is interning at Microsoft this summer.
Oh, yay.
Hey, Caroline, good to know that you joined Microsoft.
Chika,
yeah.
did you have something to say? I'm sorry, Krishna.
No,
I
no,
thought like
go ahead.
Chika was about to speak.
Yeah, I was. Thank you. So yeah, same with Jade. I'm majoring in journalism, and the most experience I've had with computer science was I took AP Computer Science in high school, but I really had fun with it. So seeing this and seeing that it kind of welcomed anyone, of any skill level, that felt like something that I could participate in. So it was really just exciting to be a part of this and kind of learn about these things I've never heard of. Like now I know about features and feature extraction. I could pull that out when I'm mingling with somebody or something, or in any application in the future. So it was really cool that I learned about these different things. So that was definitely a pro of being part of this. And I guess a negative would probably just be like, and probably something you guys can't control, but just time. It just kind of amidst it all, like I feel, if more time was spent, like we had more opportunities to kind of learn the skills that you're teaching in the workshops and like apply them. I wish I could have learned even more, but time is limited. And of course with the Zoom, time was even more limited. But I think with what you guys did and what you guys had in this hectic semester, like everyone's saying, you guys did a really great job to do what you can.
Thanks, Chika. Totally agree with you. Yeah, like we've been saying, it was a lot of it packed in a small time duration, and sometimes very broad, big picture, and sometimes very detailed. So you are all right. So again, we'll be more than happy to kind of talk to you, discuss next steps. If you want to do a project or anything, just ping us. Just ping us on Slack. Oh, and you all have Kathy's email. So Kathy is great. Just reach out to Kathy too. Shri had to step out, but I'm sure Shri is gonna watch this video. And again, Shri is a great resource. He's a great mentor advisor. So feel free to reach out to him if you have any questions, like in general, in terms of career advice, or reach out to any of us. So we're always available. I don't want to stop getting the feedback. If anybody has more feedback, go for it.
Hey, I want to like share a fun fact about Chika. I feel like others in the team will agree to that as well. But she was the one who always used to coordinate the meetings. Like as we all were mentioning that it's been a very hectic semester, and we all used to be like, this works for us, like this doesn't. She was the one like who used to come up with a common time that works for all of us. So thank you, Chika, for that.
I mean, seriously, 55% of any leadership is coordinating schedules. Surprised. Good. All right. Anything more?
As for other feedback, I just want to say I really appreciated like the alternative career paths in CS that were kind of talked about, and just like so much of the advice that was given. I think when it comes to like the CS, especially being like a CS major, but just there's so many more possibilities that really like meets the eye than just going into like a corporate job and the internship route. So I think I really appreciated that and all of your friendliness with career. And then as far as like another improvement, I definitely agree with Hannah, like with the engagement in the lectures. I think that would really help just like instill it in our memory so that we can keep using it later on. But I definitely appreciate all the videos and resources that were sent over.
Good. Thanks, Rachel. Anything more? My big takeaway was that one of the main objectives we had for this setting out was for engineers and non-engineers, computation, non-computation, to kind of meet in the middle ground, to consider both sides of the part of it. So in any research problem or any grad school, any project, the first step is operationalizing. And all the projects I saw today did an amazing job operationalizing it, thinking through the background, really thinking through it. So that's the first step. Rest is, putting things in a blender and turning on the on button, switching it on. That's how it works. So you did the first step. It was great. So I'll stop there and hand it over to Kathy.
Yeah, so definitely like all your feedback, and we really want to give a round of applause to all the mentors, because like they really did a good job, like setting everything up. I can't emphasize how much time and effort they've put into this, and to them this is also a learning curve. So they have been readjusting everything along the way to think how to make it better for you guys. So yeah, this definitely is an effort from the both side. And like I said, definitely stay in touch, and we would really like to see you guys in the future or hear from you guys in the future. And if there's nothing more, I guess, I'll just let everyone enjoy. If you're in California, it's sunny outside. If you're elsewhere, like I hope it's good weather too. And yeah, definitely we'll be in touch. And also like I'll send out another email to just fill out that survey. That is something that's also very important to us. So yeah, this is it.
Thank you.
Thank you.
Oh, and lastly, I know it's a weekend, so I really, really appreciate you all being here on the weekend and being so flexible with the schedule and really hectic semester. I totally understand it. So I really, really appreciate that. All right.
Okay.